Do you think that as AI gets applied more in healthcare, it will work in favor of increasing equity or harming the consumer?
I think it's really dependent upon who's applying it. For our use case, which is trying to increase primary care, it's really to keep those who are underserved by the healthcare space to not have to go to the emergency room when they have a fever. So I think it's just a tool,
Mhm.
and it could be used for evil or it could be used for good.
Hey, folks, Mark here. If you don't know me, I'm a scientist and also a recent convert to the camp of maybe AI isn't so useless after all. So I thought I'd bring in somebody who has a lot more experience than I do to talk about AI and where it comes from. So I'm joined today by Keith Blankenship, aka my father-in-law. But Keith is an engineer turned executive in healthcare, but has decades of experience in the field of AI. His graduate degree is in AI, so he's seen the development of this field really over the past, I'll ask you how many years, but multiple years, and can speak to where the field has come from, challenges it's faced in the past, and maybe what is or is not different now. Thank you for thank you for taking the time to talk to me, Keith.
No, I'm excited to do it. This is going to be fun.
Awesome. So can you introduce yourself and maybe talk a little bit about your background and in particular, maybe at this point, kind of where did you start out in AI and your career?
Yeah, sure. So, interestingly enough, it's 40 years ago next month that I graduated from Georgia Tech with a degree in electrical engineering. Um, at the time, I really wanted to focus on the use of software in embedded systems. So, it seemed like a great place to go would be to McDonnell Douglas, which is now part of Boeing. Most people know that, because they fighter aircraft, lots of computers, lots of software. But when I got to McDonnell Douglas, they put me in a small research and development group. And what we were doing at the time was developing expert systems, something I had never heard of before. So we were trying to build an expert system that could fly on board a fighter aircraft. And the idea was, how can we put a maintenance man in the back seat of a fighter aircraft to diagnose problems as they occur during the flight?
Can I ask you a
So that,
couple of questions? This might be naive, but can you
yeah,
explain what an embedded system is and an expert system and maybe what the I don't know what the difference
sure.
is?
Well, the embedded system is just like flight control software running on a flight control computer on the airplane.
Is that specific to aviation or that's for like any technology?
Really, any technology. In a manufacturing plant, the software might be embedded in the robots that are doing the work.
Mhm.
Those type of things. It's really contrast that with somebody writing a piece of software to interact with a bank teller or somebody like that. It's really something that runs in the background that's controlling a lot of stuff.
Okay. Okay. And then the expert systems?
So expert systems was really kind of the early AI that everybody was focused on. And the idea was to develop systems that mimic the expertise of individuals. And it did that by, there were really two pieces to it. One was what was called an inference engine, which you usually just bought off the shelf and used. And then what you did was provided a knowledge base to it. So you would write a number of rules. So you actually went through a process called knowledge management, where you would sit down and interview an expert on aircraft maintenance and say, okay, what are you looking at? When these conditions occur, what do you do? Or what's the problem? And you would build up these huge knowledge bases that would then be used by the inference engine, which would then act as an expert.
An expert to make what kinds of decisions?
Well, it all depends on what you focused on. So, like the one that we first worked with was, again, around aircraft maintenance. But I've developed a whole number of them. So the aircraft maintenance one, what it would do is look at what's occurring on the airplane, what different faults are being thrown, what is the plane doing at the time. So an
Mhm.
example might be a rule that if the plane is under a high G load and a box drops offline, well, that might be a broken wire that's being, affected by the G's. And so the output report would be check that box.
Mhm. Okay. Okay, that makes sense. So you were at McDonnell Douglas, and then
Yes,
I guess the AI part was just sort of the direction they were going in, but it wasn't necessarily your experience up to that point. So how did you get
correct.
into AI proper?
Well, so I worked on that project for a while, which was really interesting. It was the first time an AI system was ever flown on a fighter aircraft. Made a huge deal about that. But McDonnell Douglas decided to go big time into AI, as all aerospace vendors were. Lockheed, all of them were going after AI at the time. And so McDonnell Douglas made the decision to send 25 folks to Washington University full time for 12 weeks to really get up to speed on AI so that we can come back into the company and kind of seed AI, get other people thinking about it and knowing about it. So we were going to be the evangelist.
I think we all know the field of AI seems to be changing rapidly, at least from the perspective of the consumer. We're hearing about it in the news all the time. There's changes happening in companies. You talked about aviation. I think that's pretty timely considering all the discussion that's happening now about the disputes between the Department of Defense and Anthropic and how AI is being potentially used in military cases. But it's not AI is not it's not new, right? It's not new at all. It's you talked about working on it, 40 years ago. The underlying mathematics is even older than that. So, can you describe the field as it was at that time?
So as I mentioned, it's the inference engine with the knowledge base. And the focus back then was entirely on building those knowledge bases because somehow we had to represent to the computer knowledge. And so that was, you could spend weeks and weeks and weeks building up those knowledge bases and adding rules to it. And they got very complicated. And then, one thing would change and you'd have to rebuild it all. So it was very focused on the knowledge. And what I've seen different now is that knowledge is now available.
Hmm.
You know, it
So the
feels like
knowledge
this.
base, you mean like the information that the models were trained on?
Yes,
Okay. And now basically these companies are training it on the entire corpus of, you know, literature, film, whatever we have, irrespective of copyright laws.
right. And it feels like really the difference was when computers could start reading that language and understanding it.
Hmm.
Because we spent a lot of time even back in the day of how do we do that natural language processing
Right.
and just never really got to that point. So instead, you had to structure the knowledge in a way that the machine could understand it. Now the machines can just understand it exactly like we do.
What do you know when that happened? That natural language processing jump?
Oh, much later, much later. I mean, I was really kind of deep in the field until about 2000, and we never even got close at that point.
Hmm.
And it really feels like, the first time I started thinking, wow, this is really understanding me is, the early models with like Siri
Yeah.
being able to understand your questions. It wasn't perfect. And then you saw more and more of that natural language processing. And then it got the other thing that really brought that about too was the processing power.
Hmm.
Back in the day, I mentioned the expert system that we flew in on fighter aircraft. I'm aging myself here, but it was built to run on an 8186 microprocessor chip, which is ancient. And we had 128 kilobytes total of space.
So okay, just that's not a lot. I mean, I think
It's
this
none. Yeah,
the file for this recording is going to be orders of magnitude bigger than that. So
exactly.
how would the processing power, like the total processing power you had access to at McDonnell Douglas, how would that compare to like an iPhone?
It would be comparable. I can't.
Yeah.
I mean,
So we have in our pocket now the
oh, yeah.
the processing power of a major defense contractor in the 80s.
When we went to Wash U, they had a lab set up in the basement with about 20 Sun Microsystems workstations. And we thought it was the greatest thing ever. And if they had 128K of RAM, I would have been surprised.
Yeah. Yeah, that's
But
crazy.
that was state of the art at the time. Now we don't even think about that.
Right. Yeah, it makes sense then how leaps and bounds in terms of processing and like even like what a query, if you type something into ChatGPT now, that system would not have been able to handle it, at least not in any reasonable
Oh,
period of time. As it is, I think the tools are kind of slow right now, and so yeah, I imagine that will get better in the future. But I want to rewind a little bit and talk
yep.
about sort of like what is AI. And I asked this because I think we throw the term around a lot, and really I think in most public discourse now, when people talk about AI, what they really mean is large language models. And that is, to my understanding, just a subset of the field of AI. So can you talk a little bit more about, large language models were not a thing, as you just described, at that time. So
Oh, no.
what does the broader picture look like, I guess is the question.
We talked a lot about the Turing test.
Hmm.
When you interact with a system, if you can't tell if it's a human or a computer,
Yeah.
so the very early models that started getting into that Turing test area was ELIZA,
Hmm.
which is a very early kind of Siri version where you could ask questions or you could make statements and it would ask questions back to you. And at the time, everybody thought that that was amazing, but really it was kind of almost Freudian
Yeah.
psychology. It just kept asking back, why do you hate your mother? Or why do you hate this? Or why do you,
Well,
but
I
people were
imagine that
amazed.
even like current AI models, they probably would not pass the Turing test. I can't imagine that they would. You could probably specifically design a chatbot to fool somebody and maybe that would
Yeah.
work. But is it like actually inherently intelligent? I don't think so.
So I think, in this day and age, they're doing a very good job at mimicking people.
Mhm.
But I think there's certain things that that are inherent in them that it's not a human.
Right.
I don't know that they're going to get there. One of the things I'm working on right now is we're using AI to fill the gap in the primary care model in healthcare. Right now, there's 100 million Americans who do not have a primary care physician,
Mhm.
and so we're trying to use AI to fill that gap in certain ways, not by diagnosing patients or anything like that, but by doing the simplistic work. Reminding you of your appointment or telling you to get your colorectal cancer screening. So I've been very involved with that, but I find almost everybody who answers the phone and interacts with the AI, they know it's AI.
Yeah.
They can feel it. There's just something about it
Mhm.
that's not quite there
Some
yet.
uncanny valley that's
Yeah.
there with it. And some of it, I wonder if some of it is sort of like coded in, like the sycophancy you see with things like ChatGPT, where it just tells you you're the best thing since sliced bread. But even without that, there's something about it that is very non-human,
Yeah.
even if it is useful. So I'd like to learn more about the healthcare side of things. This gets a little bit closer to my field. So you after you worked at McDonnell Douglas for some period of time, you made a
Yeah.
shift into the healthcare space, and that gets you
Yep.
into some of the things you're doing now with trying to expand, I guess, healthcare access using technology. How did that
Yep.
transition happen, and how did the technology play into that?
Everybody always thinks of AI in the healthcare space as diagnosing a disease,
Hmm.
you know, like taking over for the doctor. But there's so many other processes
Hmm.
that it could help with. So I left McDonnell Douglas at the time and went to work for a major insurance company here in St. Louis. And the first thing that we looked at was the operations of paying claims. And one of the pieces that was very manual and really required a human was having a claim in front of you and then looking through referrals and determining if a referral matched the claim so that the claim could be paid.
Hmm.
A lot of things you had to look at: place of service, diagnosis codes. For a human, that's really easy to tie together, but at the time, computers could not do that. We actually built up a system that would do that and would rank order the referrals, still involve a human, but it would say, I think it's this referral with 90% probability, and here are the reasons why.
If I was going to play devil's advocate or skeptic, for this instance where you have human free systems making decisions about insurance claims, for example. I think a skeptic might look at that and say, well, if the model is trained or incentivized, like if its objective function is to maximize profit for the insurance company, which is the reason that the company exists, isn't the model going to be incentivized to find ways to deny coverage and deny claims?
I mean, back in the day, we were more explicit about the models. So it's almost like the guardrails were built in.
Hmm.
When we were at McDonnell Douglas, a big reason AI didn't make it into more systems was the whole idea of deterministic versus non-deterministic systems.
Hmm.
And AI was just barely non-deterministic at the time. And that was enough um, for the military to say, we're not sure we're comfortable with this.
Yeah, things have probably changed a bit on that front. I
Oh
mean,
yeah,
the
they
current,
definitely have.
like Claude, ChatGPT, these large language models, they're all non-deterministic. I mean, I think if you ask it the
Oh,
same question three times, you're going to get different answers each time. Um,
Yeah.
and that's something that is a little unsettling, especially if there's an objectively correct answer to something.
So back to the referral matching example, it was pretty deterministic, how the rankings occurred, what the matches were, and all of that. So it was almost an accelerator
Hmm.
that gave us a way to quickly write the rules around how to match those referrals.
Right. So it's more about automation. Like, how do we
Yeah,
take what we're already doing and make it faster?
yeah,
So if we think about healthcare, then in terms of, you mentioned that there are over 100 million people in the United States who don't have a PCP, primary care
yeah,
doctor. And so there's a big unmet need there. And there are other examples of this. You think about something like a specialty like radiology. There are so few well-trained radiologists compared to the amount of people who need to get scans of various types done and need to have those read out. And
right.
there are case studies and publications where, you know, um, uh, AI visual processing models can diagnose as well as an expert radiologist if it's trained appropriately. Now, but I think that leads to this question of, are we at a place where we're comfortable with essentially a piece of software making impacting treatment decisions for patients? And if something goes wrong, who bears the responsibility for that? And I think that
Yeah.
that's something certainly that I'm not comfortable with at this point. But how do we, do we get there? And if so, how?
And I think we should, because it's funny. I was in Austin, Texas over the summer, and a car passed me, and there was nobody driving the car. So they
Waymo.
have they have Waymo now.
Yeah.
And I thought about that, the same questions you were just asking around healthcare.
Mhm.
Even though the Waymo is probably 10 times less likely to have a wreck than a taxi cab driver, we still, for some reason, will take the risk with a human and not with the machine.
Mhm.
And it's really kind of the same in healthcare now, too. The machine's going to get the diagnosis right 99.9999% of the time. But again, it's who is responsible? Because ultimately, even if the machine makes the diagnosis, they're doing it for a primary care doctor. And are they going to trust that?
Mhm.
So
Yeah.
we're not there yet. And I think we'll get there where the machines do diagnose things, but I don't, at least in my lifetime, which is not going to be as long as you all, I don't see it where there's not going to be the doctor at that endpoint saying, yeah, I agree with that. It
Yeah.
might be that it's going to say, okay, I believe it's this condition because of A, B, C, and D. This lab test, this scan all points to this diagnosis, but the doctor's then going to look at that
Yeah. I see
from
that
there.
as a more realistic near-term win of what it
Yeah,
could look like. You could imagine that looking through all these scans and doing the differential diagnosis is like really taxing on a physician, and doing that
yes,
all day long every day. There's going to be, there's going to be a limit to how much they can do. But if you take some of that processing load off of them and what they're looking at is this is a report of what I think it is, I worry then about biasing them. Does are they seeing certain evidence that's going to
sure.
bias them in one way or another? So that's a separate thing. But if it enables them to do more and do it faster, and at the end of the day, it's a doctor who's still responsible for it. That could be a good thing.
Yeah, and we're along with what you just said. So we're already at a point where we do make recommended, we call them suspect diagnosis.
Mhm.
And they're going to be based off of lab results, medications that you might be on, specialists that you're being seen by. And so we present those to the primary care doctor. And so the doctor we worked with who helped us develop this, his statement was, I didn't go to school to be a librarian
Right.
and dig through pages and pages and pages of lab results and scans and notes. But if you present me, here's what we think it is, and here are the reasons why, I can quickly say, no, you're wrong, or you're right, or what. And he'll say they're wrong. So,
Yeah.
he's looking for that bias. He wants to make the right decision and not just say the machine's right, let's go.
Yeah, that makes sense. So, in all this time that you've seen sort of the ways that people have been trying to incorporate AI into healthcare, I mean, I'm thinking about this generally from the drug development perspective, and I don't know of a
Yeah,
single example where AI has really been used in a meaningful way in drug development. And I think that, that at the end of the day, the rate limitation in clinical development for a new drug is going to be you have to actually do a study in humans and show that it works, and you have to show
right.
that it's safe. And there's no way around that. You can't compute your way out of it, right? So I'm very skeptical about it from that angle. But I think from the system side, there's a lot more potential. So what have you seen as the wins, or maybe what is the biggest win that you've seen in healthcare?
They've been in a number of different areas. I mean, one of the early ones that I thought was fascinating, and this is around coding, which we talked about vibe coding the other day, which I've gotten into, which I'm fascinated
So here
with,
you mean coding as in programming, or do you mean coding as in like medical coding?
as in programming,
Okay.
because healthcare is a whole lot of standards from a technology standpoint. How do you interchange lab results? How do you interchange medication list? How, what does a claim look like when you send it? Because it's healthcare is a lot of independent agencies with their own systems in place. And so one of the early uses that I thought was really cool was using AI to understand those interfaces so
Mhm.
that I don't have to go out and read a manual
Mhm.
about how to use an HL7 interface to grab an admit transaction from a hospital. And so I could actually say, build up the framework for that for me. And it went from what might take days to read through to, just seconds.
Right.
So it had that knowledge about those interfaces so that a programmer could then focus on what to do with the data instead of how do I get the data.
Mhm. That makes a
So I
lot of
thought,
sense in terms of how you could imagine software like this sort of accelerating or automating things that happen in the back end. Certainly less sexy to think about than diagnosing cancer and things like that, but important. I mean, I think my experience working with healthcare systems as a patient, they're very clunky. And
yeah,
thinking about a future where things are more integrated is and smooth is pretty exciting.
we've had a lot of success in using AI to really pick out like those 5% of the patients that you should be paying attention to.
Mhm.
You've got one of the doctors I work with has over 1,200 patients, and he's one of the top performing doctors around. But he really wants to know which patients are rising in risk, which
Mm.
patients should I be paying attention to, and then using AI to really predict that. Who's at risk for being hospitalized, who's at risk for future high cost. When the patient is discharged, are they at risk for being readmitted? And that's taking a lot of input into it. And then probably a third area, again, more like what we were talking about earlier with the interfaces and all, is really around the operational area. You know, Everybody again focuses on that diagnosing a condition. That's what the doctors want to do.
Mhm.
What they don't want to do is spend 30 minutes charting,
Mhm.
uh, you know, looking at patients and calling them about, again, getting a colorectal cancer screening, or they're late for their A1C test because they're a diabetic. Not sure if you watched the show, but I was watching The Pit.
Mhm. I've seen the first season of it.
Okay, well, the second season they bring in, I'm not going to give anything away, but they bring in a new doctor.
Mhm.
And one of the things she does in the very first episode is uses an AI application to do the charting.
Mhm.
So it's doing ambient listening while she's in the room with the patient. And then when they leave the room, they open the EMR and there's a nice concise record. The thing I thought was really cool on the show, which shows that they're being trying to be realistic, is one of the residents goes, "It got it wrong."
Yeah.
You know, she's like, "Well, it's only 80 or 90%. You've got to read the notes
Yeah.
and all that, but it accelerates."
Yeah, I think that's what it will come down to is like I agree with that. We spend all this time and money training physicians. Having them spend all their time writing notes is not necessarily the best use of their time. Now, if they could instead take 3 minutes to review it and make some tweaks, or if something gets really wrong, they could revise it. And I think that's going to be an important step, and I think that step has to remain. I can't. Well, maybe the models could get good enough that that would go away, but I have a hard time imagining it. I think now I use AI a lot for summarizing meetings and emails, and put together like a to-do list for me. And the context is it kind of gets the gist of things, but the context is often pretty wrong.
We were using it the other day, and I, in the meeting, I started talking about my cat walking through the room,
And you got
and
an
that
action item for it.
made the high level summary. Yeah.
With the experience that you've had from the sort of inception of AI, or at least 40 years ago, AI, and integrating it into systems, into aviation, and now into healthcare, up to today. How do you view the public discourse that we have around AI right now? My view is there's a lot of hype, but I'm curious about yours.
which is interesting because we had massive hype in the 80s,
Hmm.
and you always have that kind of hype curve and then it drops off with reality. So the 80s, I mean, I was thinking we had a convention in Detroit for the American Association of Artificial Intelligence, thousands of people, huge it matched all the biggest conferences around. And then probably 5 years later, I'm not even sure if AAAI even existed.
Hmm.
So we definitely had the hype. And I think that's because we reached the point where it's like knowledge management became unwieldy, the tools just didn't work. Honestly, software engineering almost caught up where you could do the same thing with code. That really kind of killed it. And I had not even known this, but I was reading earlier today that they really called the 90s and the early 2000s the AI winter
Hmm.
because it kind of died out during that period.
Yeah.
So now, everything is AI. Even the stock market, you watch the stock market and it's like, well, it's driven by five AI companies, it seems like.
Yeah.
Um, but I've played enough around with it now that I think it's for real. I think the hype is what we've talked about earlier, that people are pushing it too far.
Hmm.
Even my mom, who's pretty old, she's always like, well, everybody's going to get laid off because of AI.
Hmm.
And I might have actually believed that a while ago, but I don't believe that now. I mentioned I've been playing with vibe coding.
Hmm.
And so I decided I want to build a simple model. So what I'm doing is building a web page to do retirement modeling,
Yeah.
that lets you enter your IRA balance, all that kind of stuff. So I built it up and I kept adding complexity to it. And finally, Chat GPT couldn't handle it.
Hmm.
It had an error that it just, we tried for 3 hours to fix the error and it just couldn't do it. But what I found is if I approach it like I would as a programmer, it works well.
Hmm.
So I thought, okay, let's set up our major variables. Let's tell it that there's an IRA and a savings account. How do those interact with each other? And then get into the detail instead of just throwing different things at it.
Right.
Um, so I don't see like that ever taking over coding.
It's kind of analogous to the physician example
Yeah,
where you still require the person with the training and the way to think about the problems, but that what the model allows you to do is accelerate the pieces. So the person's not typing a bunch of semicolons and open brackets. They're sort of saying, this is the structure that I need to have and put it in place,
yeah.
as opposed to true, unadulterated vibe coding, which is say, build me a retirement calculator.
So all of that I could have written.
Right.
I could have written that in 20 minutes, but it took 2 minutes.
Yeah. Yeah.
So it really is it's that accelerator.
And so
Exactly.
maybe there's a way that you could prompt it in such a way that you say, I want to build a foundational software framework that can do X, Y, and Z that's extensible. And then maybe that would work a lot better. But if you're someone who has zero programming or CS experience, you wouldn't necessarily know to do that. And you're going to run into these problems real fast.
I think so. Absolutely. That's what I've discovered the last few days.
Yeah, I mean, I think it's sort of like the technology overcame the hurdles that it had 40 years ago, but we're just going to run into new ones. And I don't think
Yeah.
that's necessarily a bad thing. I think that's kind of how technological process progress works.
Yeah.
Um, now it's running into some issues with they're out of training data. They're giving it grok inputs. Like how much more information could it have? And then I think the other thing is the fundamental limitations of what large language models can do. I believe that there are inherent limitations to that structure where it's essentially large language models are effectively looking for patterns, right?
Right.
They're looking for patterns in data and then reproducing those patterns when you give it a question. And
Yeah.
that is very useful in certain cases, but it can't do everything. It's not actually genuine thinking and reasoning.
Right. It's just pattern. It's very, very complex pattern matching.
I mean, unless there are really significant algorithmic breakthroughs in in new versions of models that come out that aren't just feeding it more piles and reams of data, that doesn't really necessarily change. Now, I do think that there are going to be new tools that come out, and those new tools will be more valuable. Like one of the tools that I use a lot, it's called Edison, and it's for scientific literature search. And it's not just
Okay.
searching and then summarizing like like Chat GPT would, which can hallucinate a lot. It's built off of those LLMs, but it has extra sort of layers of logic built on top of it, where it'll operate similar to how a scientist would, which is it's going to read a paper and then it's going to look at the papers that paper cites, and it's going to look at the papers that are cited by that paper, and it's going to try to
Okay.
come up with a consensus based on that information. And I've found that the outputs are actually very good. For me, it's like the examples you gave earlier about accelerating. So rather than me just from scratch Google Scholar searching, it's kind of focusing on me to like these are the papers that I should read that are most important, and it gives me a very quick understanding. And it has some weirdness to it. It'll give you the same references a number of times and things like that. But in general, I found the quality is really good. And so I think that there are tools that are going to be developed or continue to be developed that build on the framework of LLMs that are useful for increasingly diverse use cases. But this breakthrough, and certainly something like an artificial general intelligence, I think are just not in the. I don't think they're in the future of the models as they exist today.
Because I think we're getting to a point where guardrails are becoming really critical.
Mhm.
Guardrails are huge, obviously, in healthcare. When we first kind of played around with AI and interacted with the patient would say, I don't, this drug is upsetting my stomach. And the AI would say, oh, it's fine, just stop taking it.
Yeah,
There was a panic around that.
yeah,
Uh, 40 years ago with expert systems, we always said we could be very deep, but very narrow
mm,
on the focus. And I think we've probably gone too broad. And we're
yeah.
going to see very focused tools come out of this.
Yeah, I would agree with that. I mean, I think my experience with just maybe anecdotal experience with large language models is for anything too broad, it's not really all that useful. It's very hallucination prone. It summarizes information. That's about all it does. I asked it for. I asked ChatGPT for restaurant recommendations one day, and it hallucinated a restaurant on the corner that was like in an old Masonic lodge that was like abandoned or something. Like it didn't even exist,
Goodness.
you
Oh,
know. And
wow.
and I drove there and I was like, this is. I felt stupid afterwards because I was like, I can't believe I trusted this thing. God forbid that would be something like a medical diagnosis,
Right,
but
right.
then there are other examples of something much more specific. Like I talked about Edison for scientific literature search. That's a very specific use case, and the architecture of the software is built for that purpose. And I find it very useful. And
Yeah,
I think we'll see more
absolutely.
of that in the future. I guess just to wrap things up, if we think back on all of the years of experience you have with this and the trajectory you've seen it going, where do we go in the future with this?
So I think the future is going to be, as we were just talking, very targeted applications that are very well defined. And I almost picture them as a black boxes. So here's a black box that can, make a suggestion for a diagnosis code. Here's a black box that can interact with the patient. One of the ones we're doing is a black box that looks at all the patient data and determines what's really the next best thing I should do for that patient.
Mhm,
I really see it kind of as those black boxes that are very well defined, have the guardrails built around them,
mhm.
and then can be deployed and almost like pieced together.
Do you think that as AI gets applied more in healthcare, it will work in favor of increasing equity or harming the consumer? I mean, I think in the United States, we have many issues with our healthcare system, but chief among them is that many people don't have access to healthcare. How does AI help or hurt that?
I think it's really dependent upon who's applying it.
Mm,
For our use case, which is trying to increase primary care, it's really to keep those who are underserved by the healthcare space to not have to go to the emergency room when they have a fever,
yeah.
but to be maybe to call an AI agent and say this is what's going on and then triage that and get the doctor involved as appropriate. So I think it's just a tool,
Mhm.
and it could be used for evil or it could be used for good.
With great power comes great responsibility, I suppose. Um, if you assume it's powerful, I guess. All right. Well, thank you, Keith. I really appreciate you taking the time to talk to me about this. I think it's useful to have some perspective on well, a couple of things. I mean, I think it's useful to have perspective on where did the field come from. Everyone's been talking about AI for the past few years, but it's not new. It's been around for
Oh
decades.
no.
And I think that's one of the criticisms that people levy against all the hype is like, this isn't really new technology. It's just being applied more. And it's also useful to think about the use cases, and in particular in healthcare, where there's potential for, I think, a lot of good and also potential for evil. And it's
Yep,
useful to think about what those applications are and what kind of guardrails we should be advocating for to ensure that it's used for good.
exactly. Yeah,
So,
it's just like any other tool. However you use it.
all right. Well, thank you so much. I appreciate you taking the time, and yeah, I look forward to seeing you soon in St. Louis.
Yep, sounds good.
All right. He goes, I didn't know my dad had a degree in AI. Like, and he called you and he's like, how come you didn't tell me that? And I was like, Connor, he's told us that multiple times. Like,
It's
I
like,
even knew that. Like, I'm not sure that I could have just recalled that information just
yeah,
unprompted, but I knew, like, when you said that, I'm like, okay, yes, I remember this. And he's just like, oh, okay.